Okay, so this continuation already loaded the kernel. So now we're just gonna do the exercise. Let's see here. Oops, there's nothing here. Oh yeah, I think the deadline is I think August 22nd or 26th, I think. If you want to be invited for the kaggle team. So do the exercise for introductory or intermediate machine learning, right? And they will keep track on your progress. And if you do it like either one of them, and then you'll be invited, and then be put in a team. So, um, all right. So here's the cross validation exercise. First, just gonna do the setup here. I'm just gonna minimize this. Okay, gonna run this. Complete. The same thing happened again. We are just gonna read the data, um, and then we're removing rows with missing target and separate target from predictor, right? So over here the y is over here, and the trend data we are dropping the sell price, right? Um, okay, and then over here select numeric columns only. So we just do it over like this. X trend data numeric columns, X test numeric columns. We're gonna run this one, and then we're just gonna print out the X. I'm just gonna make it smaller so you can see better. There you go. So that's the X hat, which is the data set um, taken for the over here, just the numeric columns. So far, you have learned how to build pipelines with scikit-learn. For instance, the pipeline below will use simple imputer to replace missing values before using random forest regressor to train a random forest model to make prediction. We set the number of trees in the random forest model with the n estimator, okay, parameter, and setting random state ensures reproducibility. So here you import the algorithm random forest, importing the pipeline, and then importing the simple imputer, which is to replace the missing values, right? So we are making the pipeline here. The steps first, um, number one, simple imputer. After that, we put that into random forest, right? And then we put the estimator 50 um, as the number of parameters, which is the number of trees. Okay, you can play around with this, see what happens. So we're gonna run this. So we have also learned how to use pipeline in cross validation. The code below uses the cross-val score function to obtain the mean absolute error, average across 5 different folds. Recall we set the number of folds with the CV parameter. Okay, so we import the cross-validation score over here, and then we multiply by -1 because that's we want to use this algorithm called negative mean absolute error, and then we put this parameters for the my pipeline here. The data x and y, the one we got from here, which is just the just the numeric columns, and then the y. Hmm. So over here we are not using the uh, the whole thing. We're dropping the categorical data. Okay, because we're just getting the number columns. Columns, yeah, just the numbers. Okay, got it. And then you're using 5 folds. Okay, and I'm just gonna do this. I'm gonna print all the mean average score. It's 18,000. It's quite high. I think the last time we got is about 16,000 something. Okay, so so what is this? We'll use cross-validation to select parameters for machine learning model. Um, Begin by writing a function get score that reports the average over the three cross-validation modes, and we uses the data in X way to create false, simple imputer, random forest, and estimator parameter supplied to get a score. It's used when setting number of trees in the random forest method. Okay, so what is an estimator? The number of trees in the forest. Okay, so now we have to write the function. Okay, so I guess we can do this using hold on, get score, number of estimator is what? Begin by writing a function get score that reports the average over three cross validation. False. This is X and Y to create false. Simple imputer with all parameter left as default. Okay, so I think you can just copy all of this. Um, so you already imported here, right? Um, I think just copy this one. So here you can replace it with this guy. Um, it says using simple imputer and then using random forest regressor, random state 0, um, estimator. Oh, okay. It's applied. Oh, okay. So over here is an estimator and estimator like that. Is it the same? Um, yeah, I think so because it's the same. Okay, can do that. And then after that, you scores is number of trains. You want to score, print the score. Right? So you use this one, or probably this one too. Just copy the whole thing here. Um, and then you can put this over here. So scores minus pipeline over here. Um, X, Y. The CV is 3. Okay, so we only use 3. Still using the negative, that one. Okay, I think it's this one. And estimator parameters applied to get score is this one. Yeah, get score. Yeah, I think it's like this. Got the return value of none given n as a method is equals to 10. Oh, return. Okay. Return. So return scores mean. Like that. Uh, yeah, correct. Okay. Let's see the solution. Okay, if gets gonna score, return scores mean. Oh, yeah. Oh, just like that. Okay. You know, you can just leave it blank like that. Okay, that's almost correct. Some more parenthesis error, syntax error. Okay, step two. Test different parameter values. Now you will use the function that you defined in step one to evaluate the model performance corresponding to 8 different values for a number of trees in the random forest. Okay, 50, 100, 150. Okay, in the increment of 50. Okay. Store your results um, in your Python dictionary results when results I is the average MA cut scores I. Oh, okay. Mm, okay. Get scores. Okay, I'm not sure how to do this. Um, so get scores. I'm not sure how to do this. Okay, I'll take a look at the hint. I know what's gonna do. Begin by instanting the linear with results equals to then loop. Okay, then loop over the value for an estimator. Okay, so initiating. Okay, cool. Um, just initialize it. Okay, and then um, and estimators loop over. Um, okay, and estimator equals. I don't know how to loop over. How do you loop over? Loop in in Python. Determining loop in Python. Python for loops. Just Google it. Google is the answer. Oh, okay. Okay, cool. So I'm just gonna copy this. Okay, I think this will do. Um, okay, I'm just gonna copy this. Okay, so I think you're just gonna put the number here, I guess. 50, 100, uh, 150, um, 200, 250, 300, 350, and 400. Okay. And then for X in an estimator, okay. Um, you do what's that? Get score, get score X, right? I think it's like hopefully this is correct. Store your result in a Python dictionary. Get score X. Um, I don't know. Loop over the value for an estimator that will be plugged into get score. Um, get score. Yeah, it's this one. And use the result to set the value in the dictionary. How come is it's why is it like that? Oh, probably results equals get score X like that. Ah, or you have to indent it like that. Is it correct or no? I'm not sure. It doesn't give me a. Oh, it's still running. Okay, it's still running. Okay, it's still running. Okay. I don't know how long it's gonna take. It says incorrect. Oh, it's incorrect. Result should have 8 entries, one for each tested value. Hmm. Should I get the solution? Result does not appear in a Python dictionary. Oh, what? Oh, okay. That's interesting. Cat score 50 times I. Huh. How about if I do this instead? Okay, I got it. I got it. Yeah, yeah, yeah. Because that's I has to be I um in range 1 to 9. Okay, get score I times 50. Like that. I is not defined. Oh, X. Oh, just use this with I. I don't need this one actually. I don't need this anymore. Yeah, just like that. Just like that. Okay, almost correct. Hmm, I is not defined. What? For I in range 1 to 9. Why is it not defined? Hmm, okay, it's kind of slow, huh? Name error. Let's go, let's go, let's go, let's go, let's go. Okay, so it's just gonna go through here while we're waiting for the result to come out. So find the best parameter value. Use the next cell to visualize your result from step 2. Run the code without changes. Okay, so this is just a continuation. So it's correct. Um, okay, keys. Just gonna plot that. So you can see here. So there's 1, 2, 3, 4, 5, 6, 7, 8, right? For different data points. This is for the 53, 100 trees, 150, 200 until 400 trees. So it seems we take the highest because it's a negative. We're using a negative mean square error, right? So which means the more negative it is, uh, the better, right? But then we just put it into positive. So this one is the best probably, the 100. So given the result, which value for n estimate seems best for random forest model? Use the answer. So n estimator best is for 100. Oh, oh, I didn't know that. Are you sure? I thought it's supposed to be the, huh? Okay, I'm kind of confused now because you're using negative mean absolute error. This is not right, I think. Because if you look at the core, okay, um, the theory over here, cross validation, because it's negative. We specify negative ME has convention where all also be considered negatives. So we take the average. So a high number is better. Yeah, a high number is better. Hmm. Using negative here allows them to be consistent with that convention. Though negative ME is almost unheard. Okay. Okay. Seems not it's not clear. Huh. Okay. Anyway, so you choose the the lowest one, which is this guy, 200. Okay. So okay. Look at the hint. What does the hint say? Find the key corresponding to the minimum value in the result dictionary from the previous step. This will tell you which value for an estimator get the lowest average. Okay. Find the okay. So the minimum. Okay. So yeah, because when you do the mean absolute error, you also find the lowest one. Okay, which is correct. Um, but this one is so high number is better. So I don't know what is this talking about. Should be a lower number is better for these metrics, right? Yeah, it's just kind of confusing this one. Anyway, so keep on going, okay? Don't dwell too much on this. Just take the negative one, which is the lowest number, right? Whether it's the man absolute error, because if you look at the ordinary um, cross validation, if you look at the different exercise here, where is it? Um, let's say I think it's probably on the pipeline. Let's see, because it's using different metrics. Let's see. I think the metrics being used is this just mean absolute error. So this one, right? Mean absolute error instead of instead of um, instead of negative uh, mean absolute error. This one, where is that? Um, instead of this one, right? Negative mean absolute error. You got it from where inputs I could learn. Um, cross validation score. Yeah, this one. It's selection. What is this? It's matrix. Oh, okay, so it's kind of different. I don't know what's the difference. This is using selection, cross validation score, and then the negative mean absolute error. But it says here mean absolute error. Yeah, so I don't know. It's just kind of confusing the term, whatever. But just choose the lowest score, right? Um, Either it says negative mean absolute error or it says mean absolute error. You still choose the kind of um, the lowest score. Okay, so that's done. And then next we are going to okay. So what is this? Solution and estimator best. Okay. Oh, you can do that too. Okay. Yeah. Okay, we can do this. Like you can just run this too. Really quickly under here, code, put it here, boom, run it. Oh, nothing come out. Okay. Result key result. Um, just an estimator. Okay. Okay, 200. Okay, it's the same. Cool. Um, so in this exercise, so this is the recap. You have explored one method, just one method for choosing appropriate um, parameters in machine learning model. What is that one method? It's basically um, to choose the best trees, the number of trees by making a loop and then just comparing which one is the has the lowest negative mean absolute error. So if you'd like to learn more, go to hyperparameter optimization. You're encouraged to start with grid search, which is a straightforward method for determining the best combination of parameters for a machine learning model. Okay, cool. Thankfully, scikit-learn also continues a built-in function, grid search CV, that can make your grid search code more efficient. Hmm, okay. So this is kind of like a pipeline again, or a function that just instead of creating your own like algorithm, you just call that function grid search CV, and then basically it will kind of I think choose the bus parameters because there's so many parameters, right? Over here we're just exploring just one parameters, which is the number of trees. But I think there's so many parameters. If you look at the random, what's the name of the algorithm? If you look at the random forest regressor, I think that's the name, right? So if you look at this on scikit-learn, where is this? Random forest regressor. Yeah, this one. Just Google this thing, random forest regressor. See what comes up. Okay, scikit-learn. You can see there's so many parameters. Look at that. This number of estimators. There's one. There's criterion, MSC, maximum depth, none, minimum sample. So there's so many. It's mind-boggling. Maximum leaf, minimum width fraction, minimum impurity decrease, minimum impurity split, bootstrap, whatever. Okay, there's so many things that that you have to like mix and match. All of this kind of like confusing. So the CV this algorithm, the CV grid is just kind of automate that whole process, right? The grid search CV, this one. So it's gonna, I think, pick out the best parameter for each of those, or at least several of those, right? So that's all about it. I hope you enjoyed the session. I'm sorry, but some of the things that are kind of slow um, because of the computer and because I have to kind of figure out how to work with it. Um, please leave any comments. Give a thumbs up if you like it. If you don't like it, please don't give a thumbs down, but just recommend constructive criticism. Thank you so much. Next time we'll see you on the gradient boosting. Until next time, ciao.